Again, voice overing this video because I forgot to record sound at the same time as doing it. So the first thing I'm going to do is I'm going to write down the substitution I'm given and differentiate it, because I want to know what the substitution is for the dx. So that's implicit differentiation on the left hand side there, 2u du by dx. On the right hand side, e to the x, the 2 disappears. If I multiply out by the dx, I've got 2u du is equal to e to the x dx. I also want to see what e to the x is equal to in terms of u, so u squared plus 2. Now I want to combine these components into my integral. Now it's easier to split that e to the 4x into e to the 3x times e to the x, and the reason for that is because I've got an e to the x with a dx, which I know I can substitute with 2u du, and e to the 3x I can substitute with my e to the x cubed. So ultimately that e to the 3x will be replaced with u squared plus 2 all cubed. My ex dx is my 2u du, and then on the denominator e to the x minus 2 is u squared. There is a u in common there then on the numerator and denominator that can cancel. So I'm left with the integral of u squared plus 2 all cubed over u. And there are 2 lots of that as well. Now I do need to look for the limits. So in this case, the lower limit of ln 3, if I substitute that into my e to the x equal to u squared plus 2, then I get 3 is equal to u squared plus 2. U squared is then 1, so u is 1. Similarly, my upper limit of ln 4, e to the ln 4 is 4, so 4 is equal to u squared plus 2, therefore u squared is 2, so u is root 2. So I'm integrating between the limits of root 2 and 1. Now this is a tough question, that u squared plus 2 all cubed. I'm going to need to use a little bit of binomial expansion to get rid of that. So leaving my 2 on the outside of this integral still. My first term is going to be u squared cubed, which is going to be u to the power 6. My second term in a binomial expansion is 3, choose 1, times 2 to the power 1 times u squared to the power 2. So I'm going to list the binomial expansion, I think, for this first one so that we can see what I'm doing. So it's u squared squared, and then 2 to the power 1, plus 3 choose 2, u squared to the power 1, and 2 to the power 2. And then lastly, 3 choose 3, which is just 1. The u squared is then to the power 0, and I'm left with 2 to the power 3. All of that is over u as well. Now I need to cancel that out, expand and cancel that out. So u to the 6 over u is u to the 5. 3 choose 1 is 3, times 2 is 6, and that's 6u to the power 4, but then I'm dividing by u, so that's 6u to the power 3. 3 choose 2 is 3, times 2 squared, which is 4, it gives me 12u squared over u. I've forgotten to cancel the u there. I think I go back and do it. And then 8 over u is, of course, 8 to the u minus 1, which again I have forgotten to write down. I'm sure I'll come back and adjust that. I've paused. Maybe I'm looking for that error. Oh, I'm going to put the 2 back in. because often people find it easier to have those coefficients in front when you do the integral. There we go. Now I've put my u back in, and of course that should be 16 over u when it's all been multiplied by 2. So 2 to u to the power 5 will go to u to the power 6. 2 divided by 6 is a third. 12u cubed, u to the power 4 divided by 4 is 3u to the 4 plus 12u squared. And of course 16 over u is going to integrate to 16 ln u. That's between the limits of root 2 and 1. So now we're going to substitute these in. If I've got root 2 times root 2 times root 2 times 6 times is just 2 cubed, which is 8. So I have 8 over 3. And then I've got u to the power 4, which is the same as 2 squared. So that would be 12. 12 times 2 is 24, and then 16 ln u is 16 ln. And if you think of root 2 as 2 to the power half, that will come in handy later when we're using our ln rules of logs. And that's all subtract. Substituting 1 is much nicer. That's 1/3 plus 3 plus 12, and then 16 ln 1, of course, anything to the power 0 is equal to 1. So that's equal to 0. Now then, 8/3 take away a third, just to get rid of the fractions, is going to be 7/3. And then if I add 12, add 24 is 36, and then take away the 12 is 24, take away the 3 is 21. So we'll be adding 21. And then lastly, I'm using the rules of logs to bring that half and multiply the 16 by the half so that I can write 8 ln 2. And let's do 7/3 add 21. 21 times 3 is 63. Add the 7 is 70 over 3 plus 8 ln 2. And if I look back to what this question wanted at the start, I think it wanted it in terms of A, B, C, and D. So A is 70, B is 3, C is 8, and D is 2.